Good morning, dear students. In today's lecture, we will talk about the most important topic of this chapter, that is rate law or rate equation. See, we have talked about the factors affecting rate of reaction, and there we have discussed that concentration of the reactant can affect the rate of reaction. Normally, if we increase the concentration of the reactant, then rate of reaction also increases. Generally it is there, not every time, but generally it is there. So what is rate equation or rate expression or rate law? The equation or the expression which relates the rate of reaction with the concentration of the reactant is called rate law. So let us talk about a hypothetical reaction where A and B are the two reactants. On reaction, these are converted to C plus D. It's a hypothetical reaction. Then we can write that rate of reaction will be directly proportional to concentration of A, and rate is also directly proportional to concentration of B. Let us change the equation. Let us have some stoichiometric coefficient also. So in next hypothetical reaction, we are using M1A. M1 is the stoichiometric coefficient of A, balancing mole. M2B, M2 is the stoichiometric coefficient or balancing mole of B, reacts to give you N1C plus N2D. For this hypothetical reaction, the rate will be written as rate directly proportional to A, then to the power M1. So rate proportional to concentration of A to the power M1, and for B it is related as rate directly proportional to concentration of B to the power M2. So removing this sign of proportionality, we can write rate equals to K into concentration of A to the power M1 into concentration of B to the power M2. So this is the complete expression which is relating rate of the reaction with concentration of A and concentration of B. And this complete expression is called rate law. Here, K is a constant, which is called rate constant or velocity constant, or it is also called specific reaction rate. M1 and M2 can be stoichiometric coefficient of the balanced chemical equation, or sometimes it is not. So M1 and M2 are not always the stoichiometric coefficient that we are getting from balanced chemical equation, because value of M2 and M1 are determined experimentally. Every time it is not balancing moles. we have to see the reaction, how changing the concentration is increasing the rate of reaction. So important point here is M1 and M2 are determined experimentally. Sometimes it is according to the balancing mode and sometimes it is not. And M1 plus M2 is called order of reaction. So what is order of reaction? The sum of the powers to the concentration term, which is written in rate law, is called order of reaction. Again, sum of the powers to the concentration term, which is written in rate law, is called order of reaction. An important point here, unit of K depends on order of reaction. If value of M1 plus M2 is 0, it is called zero order reaction. It is possible that the rate of reaction does not depend on the concentration of the reactant. Value of M1 plus M2, it can be 1, first order reaction. Value of M1 plus M2, it can be 2, second order reaction. Or it can have fractional value also, 1.5. That we will talk in our next lecture. So unit of K depends on order of reaction. If it is zero order, its unit is different. Different than first order, different than second order. Then comes the characteristic of K. It is the most important part of any chemical reaction. So what are the important points related with K? Point number 1, value of K is different for different reactions. Different reactions have different value of K. It does not depend on concentration as it is an intrinsic factor. If you are changing the concentration, it will not change the value of K at a particular temperature. That's why it is a constant. That's why it is a constant, but depends on temperature. For a particular chemical reaction, the value of K obtained at 25 degrees Celsius is different than the value of K obtained at 35 degrees Celsius. It does not depend on concentration but depends on temperature. Temperature dependent term. Third value. The magnitude of K will decide whether the reaction will be fast or slow. If larger the value of K means faster reaction, if value of K is high, it shows the reaction will be faster, and vice versa. Low value of K means slow reaction. And the fourth point, at a fixed temperature, the value of K is constant for a particular chemical reaction. So that is all about the rate law or rate expression or rate equation. The important point in this is properties of K and order of reaction. That's all from my side in rate law or rate expression. Thank you and have a good day.